All right, so our last solid that we're going to deal with is a sphere, which is a very unique shape because if you look at it, it's basically your ball, right? It's just one smooth surface, all continuous, no bases, no edges or anything. So before we talk about our formulas for the sphere, just a couple or a few vocabulary words to recognize. So first off, well, what makes a sphere a sphere? It's basically like a three-dimensional circle. So it still has a radius, just like a circle does. And that radius is the same distance anywhere from the center of your sphere to any point on the surface of the sphere. So that means it's not limited just to this green circle, right? We can go to this red circle. You can go anywhere onto the surface of your sphere, and those are all congruent, and those are all the radii. Now, we specifically call this red circle the great circle because it's the largest circle around the sphere. So it's the circle that cuts the sphere in half. All right, so that's, again, the largest circle we can get around the sphere. And then that great circle creates what we call a hemisphere. And a hemisphere, like you've probably heard about in like geography, right? Northern hemisphere, southern hemisphere, it's half a sphere. Okay, so that's just some vocabulary to go with our spheres. And then we really just have a couple formulas to do with spheres. And then we'll move on to looking at some composite solids to wrap up Unit 10. So the volume formula for a sphere is 4 over 3 pi r cubed. Think cubed because we're dealing with volume. We're looking at the space inside. R is the radius of your sphere. Okay, so we want to be able to use that formula in any way we need to. So if we look at example 1, we have two parts to this. We're going to leave our answer in simplest radical form or in terms of pi, depending on whatever we're doing here, and just calculate what we're asked to calculate. So example 1a asks you to find the volume of a sphere with diameter 24. So remember to look at the directions, know what you're looking for. I want to find volume of a sphere. So I know what I'm looking for, I know what shape I'm working with, and that tells me immediately what formula to pull out. 4/3 pi r cubed. So all I need to know is radius, and then I'm good. We know diameter is 24. What's the relationship between diameter and radius? Right, diameter is 2 radii. So if 24 is our diameter, radius is 12. So let's go ahead and plug it all in. So 4 over 3 pi times 12 to the third power gives us 4/3 pi times 1,728. We're leaving our answer in terms of pi here, but I could also ask you to round. So remember, if you're rounding, you want to use the pi button on your calculator. But here we're not going to round, so we're going to leave it in terms of pi, which is 2,304 pi cubic inches. Right? So just another formula to know and work with. But remember, as with all formulas, we don't always have to solve for just volume or surface area, right? We can solve for any missing piece. And in this case, we can go backwards and find the missing radius, or by extension, the diameter. So that's what we're doing here in part B. The diameter, we're looking for the diameter of a sphere with volume 36,000 pi, and that should be cubic inches. That's a typo. So 36,000 cubic inches. So we want to remember, okay, I'm given volume, so that tells me the formula I'm going to work with, or at least one of the formulas I'm going to work with, 4/3 pi r cubed. I know I'm looking for a diameter, but in the formula I'm given radius, so we have to go back and think, oh, right, we said earlier diameter is 2 radii. So what we want to do now is hopefully pretty clear. Use the volume to find the radius, then multiply that by 2, right? So let's go ahead and plug it all in. So 36,000 pi equals 4 over 3 pi r cubed. Remember, pi is just a number. We can divide by pi just to get rid of that right away. And then we have 4/3 r cubed. Remember, don't deal with that cube until the very end. So let's get rid of 4/3. So it's up to you how you want to deal with this. You can do this in 2 steps. You can do it in 1. I'm going to go ahead and show you the 2 steps. I'm going to multiply by the denominator, which is 3. So I'm going to get 108,000 equals 4r cubed, and then I'm going to divide by 4. That is the same thing as multiplying by 3/4, which is multiplying by the reciprocal right away if you wanted to do that. So we get 27,000 equals r cubed. So now I have to dig into our memory and think back to Algebra 1. What's the inverse operation of a cube? We know the inverse operation of a square is a square root. So what's the inverse operation for a cube? Well, we're going to cube root it, right? So the cube root of 27,000 is going to be equal to r, because we want to get rid of that third power. So, oops, let me rewrite that a little bit clearer. So we cube root both sides of our equation, and then r is equal to, and hopefully you guys know where that cube root button in your calculator is. It should be usually a second function. You'll see like an x and a square root. So you put in a 3 first, hit that button, or something like that. I can help you out if you need help with your calculator. But do that cube root and we'll get 30 inches. But don't forget, we're looking for diameter, so always keep in mind what we're looking for at the end. So diameter is 2 times 30. Diameter is just the length, so it's going to be 60 inches. And there we go. Okay, so that's our formula for volume, and we can play around with that and do different things with it. And then we also have surface area. So surface area of a sphere, the formula is actually pretty straightforward. 4 pi r squared. And always think surface area, area squared, so that's where we're squaring it, versus volume is r cubed. Because really the only length, the only kind of dimension here in our sphere is a radius, so that's why all of our formulas use radius. So remember, it's r squared for surface area, because area is squares, r cubed for volume, because cubed for volumes, right? All right, so just 2 examples of how to work with this surface area formula. So again, we're going to leave our answer in substitute article form if we need to, or in terms of pi, so basically not rounding. But again, I could always ask you to round, so use the pi button to practice rounding. So example 2a, we want to find the surface area of a sphere with great circle that has an area of 49 pi square miles. All right, so always starting from the beginning. What shape are we working with? What are we trying to calculate? Let's start with some formulas, right? Surface area of a sphere, just went over it, 4 pi r squared. So in order to find surface area, we need radius. But in our problem, we're like, wait, what's the radius? I don't know it. But I do know there's a great circle that has an area of 49 pi. And if you remember back in our picture, if you have the sphere, right, the great circle is the biggest circle around the sphere, which means the radius of the great circle is equal to the radius of the sphere. So let's go back and think, wait, area of a circle. Area here is pi times radius squared. We can work backwards to find r, right? So we want to use all of the shapes that we are familiar with and are comfortable with working with. So 49 equals r squared, square rooting both sides. Remember, radius is a length, so we don't want the -7, we just want a +7. Now that I have my radius, we're all good to go. So surface area is 4 pi 7 squared. And you might even realize, wait a minute, if pi r squared is 49, can I just put in 49 for pi r squared? You totally can, right? As we make that connection, you're good. So again, kind of up to you and what you're comfortable with. Again, I'm not rounding this one, so we're going to leave it as 196 pi. Again, this is surface area, so make sure you have the right units, square miles. But if I wanted you to round it, please use that pi button. Don't use 3.14. Okay, last example here for example 2, working between surface area and volume. So this is also really, I think, kind of fun to do between surface area and volume of a sphere, because there's only one thing that these 2 formulas share, right? Volume is 4/3 pi r cubed. Surface area is 4 pi r squared. So what's the one thing you need to know to find both of these? The radius. So we're given the surface area, so we want to use that to find the radius so we can go back and find the volume. So we can kind of make that whole connection, and then our plan is golden. So let's take that 324 pi, put it in for surface area. I'm going to divide by 4 pi because those are just numbers. You can divide by 4 first and then pi, it's up to you. Pi cancels out. 324 divided by 4 is 81. Square root both sides. Again, I'm ignoring the negative square root, not because it doesn't exist, but because it's not a length. So our radius is going to be 9. And that was our only missing piece to find volume. So 4/3 pi times 9 to the 3rd power. Again, not rounding because it says in the directions to leave it. So I'm going to go ahead and multiply my fractions. 4 times 729 divided by 3. right? So we want to make sure we use our fraction multiplication correctly. So that's going to give me 2,916 over 3. And then always double check to see if it simplifies, right? And this simplifies very nicely to 972 pi, and we're doing volume, so cubic inches. So that's it for spheres, our last solid in Unit 10. Okay? So now that we're done with spheres, we can move on and talk about a couple more things. So we can look at, changing dimensions. We can also look at this idea of composite solids. So we talked about changing dimensions back when we dealt with area and perimeter and circumference, right? So we can take a look at the three-dimensional shape and kind of work with the same thing. There's a relationship that we can recognize here. And remember, with our sphere, there's only one dimension. So we're making a similar solid, right? If we change the radius. So as long as we're still dealing with similar shapes, area, that relationship is still going to be the same. We multiply by the factor squared. And volume is just cubic, so we're going to cube it. Okay, so let me write down these relationships. So again, if all dimensions are changed, when you think area, area is still area, it hasn't changed from before. We're going to square the factor. Volume, think the units, it's cubic, so what we're going to do is we're going to cube the factor. So for this problem, right, if the radius is multiplied by 3/4, surface area, oh, sorry, that's super messy. Let me try that again. Surface area is multiplied by 3/4 to the second power, so 9/16. And volume is multiplied by 3/4 to the third power, so 27/64. And that's it. If you want to calculate it, you could definitely try to calculate that and do new divided by old to find the factor, but I think it's pretty straightforward to just, use these rules. Okay, then last up, what happens when we put shapes together? So this is where we can kind of synthesize our different formulas. So these are called composite solids, just like how we had composite shapes for 2D, we have composite solids for 3D. And what we need to do is really think about how surface area and volume are different. So when we deal with surface area, you're thinking about everything you can touch. So let's think about what's going on here in A. We actually have a rectangular prism, and we have a cylinder taken out of it. So this is basically a tunnel or empty space. So then if you're thinking about what we're touching in terms of surface area, we originally had this big rectangular block, and then we drilled the cylinder inside. So we've lost the circle on top and the bottom, but we've gained this smooth tunnel inside that we can now touch, which we couldn't before because it wasn't open. So when we're dealing with surface area, really think about what's accessible. And in this case, what we're going to do is we're going to find the surface area of the prism, add the lateral area of the cylinder, because remember, that's the curved tunnel inside, but we need to take away two areas of circles, right? Because we have to be able to get into that shape. So that's the plan for part A for surface area. So surface area is a little bit trickier because you have to think about what you're adding, what you're subtracting. Volume, on the other hand, super nice. Volume, it's just the space inside. So what you're thinking about is okay, if I took out this little cylinder, this little tunnel inside the shape, does that increase or decrease the amount of space inside? Well, it decreases it, right? Because we took it out. So volume is straightforward. We're either adding or subtracting. No necessary additional subtraction because of extra space or whatever. No, it's just either you're going to add it or you're going to subtract it. So we're going to take the volume of the prism and then take away the volume of the cylinder. All right, so that's our plan. I'm going to come back and do the calculation so you guys can check your answers in a bit, but let's go ahead and think about a plan for part B. So you guys think about this. What do you think you're going to do for part B? Well, hopefully you saw for surface area, which is a little bit trickier, we have a hemisphere on top of a cylinder. Now the hemisphere doesn't come with a base on it, right? It's just cutting a sphere in half, and the sphere doesn't have a base. So we don't have to worry about taking away a circle from the hemisphere, but we do need to take away one circle right here from the the cylinder because you're basically putting a dome on top, so we can't touch that top anymore. Volume, we're adding, so pretty straightforward. All right, so now that we have our plans down, let's actually go and calculate, because once you get your plans, I think the easiest thing to make a mistake on is, of course, the calculation. So go back and go ahead and calculate surface area volume for A, surface area volume for B, based on the plans that we see, and then we'll check our work, and that'll be it for Unit 10. All right, guys, so let's go ahead and check. So hopefully volume is pretty straightforward, and I realized I forgot to say I wanted you to round for these. So if you left it as an exact value, it'd be 7,680 minus 320 pi, which rounds to about 6,674.7 cubic feet. Surface area is always the one I notice students find a little bit trickier. So remember, there are also other plans you could write here. You don't have to do prism minus cylinder plus prism plus cylinder minus 2 circles. You could do lateral area of the prism plus 2 squares minus 2 circles plus lateral area of the cylinder. So there's different ways to write your plan, but what's important is you get the same final answer. So we should get 2,770.1 square feet. And if you look here in red, I have each of my components. So the surface area of the prism, the lateral area of the cylinder, area of the circle. So you want to make sure you're still using those familiar formulas correctly. Okay? Then for part B, here are my calculations. So volume, pretty straightforward, adding because we're adding space. So that becomes 468 pi, or about 1,470.3 cubic inches. And with surface area, again, this is one possible plan. You could, of course, do something a little different. So I've seen people do the hemisphere plus lateral area of a cylinder plus 1 area of a circle, which is fine too, because we get the same final answer, which is 216 pi. Okay, which rounds to about 678.6 square inches. All right, so that wraps up spheres, composite figures, and our Unit 10. Please let me know if you have any questions.